Hey, how's it going, everyone? My name is Mike Curnow. Made a few changes to the presentation. We're actually going to be talking about the granular history of unshielded twisted pair. No, I'm kidding. I actually want to be welcome back next year, so we're not going to do that. Yeah, it's kind of boring. But what I am here to talk about is cyber to physical, IT convergence. I kind of feel like I have to flood this with memes and GIFs because I realize I have the after lunch position. Everyone's stomach is full, people start getting the itis. That forces me to be much more interesting in the presentation. So before I descend into my standard demeanor of delinquent, casual brevity, I'd like to take a moment to say it's really awesome being here. This is my first BSides event ever. And now that I'm here, it's definitely not going to be my last. So yeah, really great job everybody who came before me. Also makes my job hard to get up to standard. Yeah, so who am I? A little bit about who I am. Personally, I spend a lot of my free time doing software development, creating open source tools, helping people with open source tools on GitHub or Bitbucket. You wouldn't believe it, but I actually do a lot of public speaking. I spoke at 3 conferences this year, a couple of panels, and I've been doing security meetups for the past 3 years. I spend a lot of time exercising. However, that doesn't help me on these stairs. I play a lot of Xbox, Halo 5, really. So if you play Xbox One, hit me up, talk with the boss. I'm an avid football fan. I kind of feel like I'm going to lose like 90% of you when I tell you what team. Or I could just sit back and collect all the adulation. Oh no, I didn't expect this. So on the professional side, cybersecurity instructor for the Coder School, which is it's a after-school initiative that mainly teaches kids how to program, but I run the security class there. I'm there for about almost 3 years in October. And just a quick screen capture GIF of the website. Check it out in your free time. So I wear a few hats, right? So I'm also the co-owner and chief information officer of a financial analytics company called RapidCat. And what RapidCat does, so that's the most professional you're ever going to see me on camera. What RapidCat does is it's a platform that aims to kind of decrease that intellectual barrier of entry for people that are trading in the Forex binary market. And last but not least, I'm the lead security operations center architect for Block Harbor Cybersecurity. And so what Block Harbor is, we're a cybersecurity firm based out of Detroit, Michigan, and we have a pretty firm foothold in the cyber to physical space, mainly automotive. And so what we do is we actually help secure the cyber to physical systems that these major automotive OEMs out there use. And I'm also the former head of cybersecurity for an international MSP called Same Analytics. Also former PSYOP in the Army. The same guy, just without the scarf. So security acumen, just kind of a little bit about my security experience. I've done red team side, right? Like we've all done pen testing in some form or another. So pretty much everything that ranges from a standard network to web application, mobile application for things like everything from IAM management platforms, banking platforms, hotel financing, really any, not everything, but a lot of things. I've done blue side too, so I eventually got into the engineering side, specifically developing a custom in-house SOC utilizing Elasticstack and then being able to integrate that with other in-house tools, creating a pretty good functioning SOC from that. And so some of the positions I've held in that space is engineer, analyst, and team lead. So right now I actually lead a team of 2 analysts. And then right now I'm lead architect. So what that means is being able to, like basically what I do for Block Harbor is I create an architecture for how to set people up with our SOC, and then I turn that architecture into working infrastructure. So all the plumbing, all the connecting, all that stuff is what I do. And we're I make my bones at nowadays is industrial control systems, cyber physical devices. So I got my start actually. The first job I ever had with cyber physical assessment was a piece of major metropolitan public transport, right? My first time ever. But I rolled with it and it actually turned out really well. And so that kind of lit the fire, the passion of cyber to physical security. So I also do a lot of research in industrial control system and operational technology security integration. Basically how to secure cyber to physical systems. I'm using a lot of repetitive phrases, I'm sorry, or not. And automated tank gauges, so gas stations that use automated tank gauges plug this stuff right up to the internet for some reason. So really quickly, just want to go over what I won't talk about. Can you guys see that? Good. Okay. Because I don't want you to read it. It's literally it's literally just a list of very minute, granular regulations and compliances that if you're even fathoming putting your stuff on the internet, you should have all these covered. Yeah. So what I am going to talk about is Industry 4.0, what it is and what the problem with it is, and some proposed prospective solutions. So basically, how many of you guys in here have worked with industrial control systems, PLC, SCADA, IoT? Okay, so a couple of you guys don't chastise me because I will be covering notional concepts. Just trying to build a secure mindset with it. So if somebody says, hey, that network architecture is not going to work, cool. The idea with what I'm going to show you is basically just try and get that mindset there. And now I'm going to do some demos. So what some vulnerable nodes look like in the wild. Really, we're just going to be doing a little bit of showdowning. We're going to rage against the machine by just screwing up a PLC. Then that's what this is here. This is my PLC and my automated tank gauge and my MQTT IoT broker. We're going to get into MQTT broker mischief. MQTT is a protocol, device-to-device protocol that a lot of IoT solutions use, and so we're going to just mess with a sensor or two. Then automated tank gauges, so we're going to be passing gas, tanks. I got to set up, oh yeah, if anybody has any questions about anything, either just get at me at the end of the slide or after the presentation is fine. So to build a little bit of historical context as to what Industry 4.0 is, we got to understand what Industry 1, 2, and 3 are. And so I'm not going to read every single thing here, but pretty much mechanization kind of helped us pivot our infrastructure and economy from agriculture to building shit. So then from there we have the steam engine. So with the steam engine, we subsequently created ways to massively extract coal really quick. We're also able to accelerate the economic, material, and human-driven stuff. So like people taking trips, transporting things that expire, like meat or something. And then this actually is like the original creation of like, it's helped build the blueprints of how we operate industry today. Industry 2.0 started late 1800s, so new energy, gas, oil, electricity, combustion engine. So the combustion engine means that the steel industry had to grow rapidly. And after that happened, we have new communication formats and we have new transportation. Industry 3.0 started 1969-ish. So we have nuclear energy. We have did I say nuclear? We have nuclear energy. So we have new electronics, so transistor, microprocessor, all that stuff. And we have automation through robots and programmable logic controllers. And so Industry 4.0 is now, there's a whole litany of crap here. So virtual augmented reality, additive manufacturing. Additive manufacturing is actually really huge, obviously, like 3D printing. Normally manufacturing comes from the fact that we take raw materials and then whittle away at them until they become the form we want them to, but with additive manufacturing, you're just creating from nothing, which is awesome. Internet of Things, shit's everywhere. So I don't want to read all that. So big data, the ability to process large amounts of data, create predictive analytics, machine learning. byproduct, being able to use big data, cloud computing, advanced simulation, to be able to simulate things that are conducive to cost control, things like that. Autonomous robots that can think, please disregard that spelling error, that can think, act, and react. Universal integration is basically the communications between different systems. That's done in lots of different ways. And cybersecurity, because for us to advance as a culture and as a people and as the human race, we need to be able to keep Industry 4.0 going so we can do Industry 5.0 at some point. Stuff doesn't work if it's not secure, right? So all of us in this room have real big shoes to fill. So the problem as I see it from a professional standpoint, there's a large influx of companies that want to be industry relevant. So what happens, I got ahead of myself, what happens is they want to meet the needs for communications management analysis, right? So companies that utilize cyber to physical technology will put their stuff on the internet haphazardly, not trying to be disingenuous, just trying to meet a need and increase convenience. So here we just have like a sample cloud dashboard for a SCADA system. SCADA is a supervisory control and data acquisition. It's kind of like the management for different PLCs under it. It's a little more complicated than that, but that's the easiest way to explain it. So here we just have like a quick dashboard. No product plugs or anything. It's more so just to kind of show what some of these cloud dashboards look like. They want to be able to manage these things remotely, right? And so here we have like an IoT, smart home type management device, light switch and temperature and all that. Here we have like a ATG monitor. Does pretty much the same thing. Monitors gas tanks and tells you how much of what you have. And so the way that I see this process go when I talk with people and work with people starts off, organization puts their PLC on the internet, right? Is this IoT convergence? And then the organization drops the ball on cybersecurity. So the ball represents the security, and the organization is the guy that dropped the ball. And then they fall flat on their face because something really bad happens, right? So I just want to say, what's up to some scary stats. This was done a few weeks ago, the numbers I got, so they might be a little bit more now. So ICS OT devices that I found in the wild, 21,000 Modbus devices. Modbus is the most prolifically used protocol for either PLCs or other cyber to physical devices. You see a crap ton of it. Honestly, some of these are honeypots, but they're not all honeypots. Siemens S7, DNP3, devices that use a DNP3 protocol. Tritium devices, 35,000. BACnet, 19,000. I'm just going through stats here. Then we have IoT MQTT brokers. Here's a quick screenshot a couple weeks ago here. That's a pretty scary number because the MQTT broker, what it is, it's not the IoT device itself, but it is the catalyst of communication between smart devices. And that's why it's scary to me. Automated tank gauges, a good amount. Not high comparatively, but still enough. And, oh yeah, demo time. So let's do some demos. So the demos I have set up, I already went through them. I've got a Modbus PLC lab, I've got an IoT MQTT broker, and I've got an automated tank gauge demo. Oh, whoops. This is a video just in case something happens with the demo. So pretty much I did some testing with my hotspot here, and when I tested it in this room, things got kind of weird and choppy. So if that happens, I'm just gonna remote. Oh yeah, I'm forgetting the whole Shodan thing. Here we go. So real quick, like here, we're just gonna take a look at what Shodan sees on the internet. And we can see there's a bunch of stuff here. I don't like this because I'm not paying for this crap, and it's got like 2 pages I can go to. So instead what I do is go to Maps, Granted, this loads well. This is kind of hit or miss. Like sometimes I can pull these up just fine, and sometimes it kind of bugs out. So really quickly, let's take a look and see if there's any devices in Asheville. There we go. I almost forgot where Asheville was, which is terrible because I come here like once a year for work. So let's just take a look and see what that is. Okay, so this is a PLC that's open, or this is a Modbus device that's open. The scan that Shodan uses did not really produce any good results. We just have one line with an empty value. So let's go here to Silva. There's another one. Okay, that's also, I'm looking for something that has more than one line too. I'm just going to go back to the, that didn't work. Okay, so here we go. So right here, we can see in Poland, we have a device that looks like it has it's got three different IDs, so these could be for different functionality, but we're getting some stuff. Oh, we can also see illegal function. So when you see that in wild, that means that we actually can't access this, but don't try this though, because there's like this legality thing. So here we go. These right here, because it doesn't come back with the slave ID data, legal function error, we should be able to interact with these. So at least be able to like read the holding register address values or read the coils in them. In a PLC, the coils contain the program logic, and the holding register address values are values that can be anything. They can be the weight of something, the height of something, the temperature of something, whatever it's controlling, those values mean something, even though they're not always really human readable. You have to be on the inside to really know what that means. So enough of that. Really quick here, we can see we have a few MQTT brokers that are online. Most likely, this MQTT broker is running Mosquito, and the reason I say that is because so these are called topics, right? And so at the beginning of a topic, we have the $sys. Mosquito is a tool that does do that. But if you scroll down, we can see ActiveMQ is also another MQTT broker. So it normally starts with something indicative to what the device is. Yeah. So can everybody see this okay too? I haven't even been thinking about that. Okay, here we go. All right, can everybody see that? Or I'm not sure, it might not be. Yeah, it looks fine to me on the screens. I don't know. Here we go. So this is most likely a Mosquito MQTT broker. This says right here, it's ActiveMQ, which is just another tool. It's another MQTT broker you can set up. I can't recall if this one's open source or not, because I've only done testing with Mosquito and not with ActiveMQ. So here we have gas tanks. And here we can see a lot of, scary enough, but a lot of local gas stations have these automated tank gauges that they stick right in the internet, again, because they probably sign up with some sort of service, a cloud dashboard or something. It's like, hey, open up this port on your network device and just let us hook in. Like, oh, cool, I can see all my stuff, but so can other people. Sorry, what's that?
Just enable UPnP.
Yeah. So so here we can see, so pretty much what this is a telnet session. And so you can look up vendor commands for this, just type in automated tank gauges, and you can find a couple of brands. There's one that sticks out more than most that's pretty highly used. But we can see right here, there's this command right here is actually entered via telnet. The 201 command, that's to list your inventory, what you have. There's a couple of commands you can do, like the one to restart the tank gauge is pretty cool. That means that people can't pump gas I like that one. So, all right, so that happened right as I was doing my terminal here, so the demo gods have answered me. I really want to try and make this a bit bigger here, but if it takes more than a couple minutes, I'm just going to try and explain really well what's going on. Don't know if that worked.
Seems bigger.
Does it? Oh, there we go. Yeah, I've had this laptop for so long, I didn't even know I can do it. See, you learn new things at conferences. I got to make sure these are the same size. Yeah, they look. Okay, that's terrible. All right, cool. So now we can see that. So we're going to be working with the tool that I built to actually help me with my very first SCADA security assessment. It's called Rapid Fire. The reason I called it Rapid Fire was because I needed to address a need to test multiple holding registers addresses at once. The socket tool that I was using can only handle one of these, so I had to create a small Python script that would just automate given a list of addresses. And I had turned it into a tool because of free time. So really quickly, we're going to kind of go through these. We're going to use the Modbus module first, and we're going to use this Modbus pen test framework here. Cool. So I stuff doer because it does stuff. Show modules. We can see a couple things here. When you find a Modbus device that you want to mess with, you need to get a couple things. Get a UID. And then, okay, our UID is 1. So the tool's a little bit buggy as far as going back to the beginning, but that's fine for now. So now we have our UID of 1, so put that in the back of your brain bank thing. Now we want to identify the functions. We want to identify in what ways can we interact with this device. I'm starting to think Thunder's a good sign now because everything's working.
Yeah.
I forgot. Okay, so set our target again to that, and then set UID to 1, and then so we're printing out the function codes. So read coils function 1 is supported. That means that I can send a request to say, hey, give me your coils, or tell me what they are. And it's really just binary zeros and ones. Then we have read multiple holding registers. So that's really important because that allows us to just kind of identify which holding register values have addresses in them, or have values in those addresses, so you can kind of pinpoint your attacks if you want to. Or you can do what we're going to do and just rewrite all of them. Again, I have to repetitively start this, that's fine. So anyways, we've seen that a few functions are there. We can read coils, we can read holding register address values, we can write to multiple holding address values, and we can write to multiple coils. 2 things we need to make some SCADA sysadmin's day. I'm being sarcastic. They wouldn't like that. So we're going to go ahead quick like here. So these 2 terminals right here, these are going to be listing the coils, right? So your zeros and ones. And these are going to be, this is going to be listing the holding register address values. Again, these could be anything from the outside in. We have no idea. So what's going to happen is I'm going to go ahead, do a thing. Then our start address, we're going to start at 1. So we put 0, enter. And then if, what's it good? We'll stop at 20. I'm putting 28. So then we just enter what we want to do. Let's just do this. All right, now watch these. They're all different. They're all 69. So let me go back. There are ways too where you can actually you can just pinpoint them if you use a smaller range. That's why reading what these are helps so that you're just not rewriting all of them if you want to be a little bit more stealthy. But just for example's sake, we are doing that. And then, so we're going to do the same thing with the coils. We're doing here is we're just going to break the logic of that controller so that, like, I don't know, some machine fails and drops and hits someone. So we're going to start here and so we're going to put a 0 or 1 in. Because there's more zeros, I'm just going to put a 1 in. Whoa, look at that. 1s. So that's the Modbus. Next, we're going to do the MQTT. So basically what we're going to do, the way I wrote this module is a little screwy. It utilizes 2 Python subscripts, so I got to enter the address a second time. So if you're wondering to yourself, why the hell is he doing that? That's why. So you can see here I've got MQTT set up. You can see sensors, sensor 3542. This is a light switch, right? Notionally, it's a light switch.
Magnify?
Huh?
Magnify? Possibly change the font color. Blue on black is terrible. Bad as green on green.
I might need to go bigger. Hold on. Okay. Okay. So, yeah. Thank you though for saying that. I would have kept going. So yeah, this is notionally a light switch. So you have on-off function. So we're going to do down here. We're going to write a string value to it. It only accepts on or off. So if it's, oh wait, hold on. I need to first subscribe to the topic so I can write to it. Then we have to, my spelling is off. I guess apparently I'm going to public this topic. I made some last minute changes before doing this today, so we're going to write to control. Control is just the default, and we're going to write on. So before it was off, it should be on. So if you get message received on, that means that it worked, but you want to double check it. Oh, Jesus Christ. I forgot how big I made that. So we're just really quickly just kind of parsing through the output. Oh, hey, look at that. We're on. So that's that. I mean, this really isn't super impressive for the most part. It's the reason I show this is because people put this crap on the internet. And these are just some things you can do to it. So next, we're going to get into automated tank gauges.
For example, if we found that somewhere and that light switch was hooked up to a power brick on a wall, then we might could hit that,
Yeah.
turn it on and off, and not make the lights flash or whatever.
If somebody has it hooked up in that way, yeah. And you'd be surprised. Like, you just go to Shodan, you'll see loads of MQTT brokers on there. And if you can get it to print out its topics, chances are you can probably subscribe and publish to those. And you'll know if it worked because you get that message received. Depending on, like most of the brokers follow kind of a similar-ish schema almost, so you should get some kind of response message back saying that it worked. So from here, let's do automated tank gauges. 10,001 is default port. However, it's also default port for a specific Ubiquiti network device. So you want to make sure that when you're looking at these, you can telnet into it, and running the 20100 command, you can just print out of that the inventory, or you just go to Shodan and it does it for you. Because Shodan basically takes, it says, oh, you're running 10,001, I guess I better telnet into you and run this command. So now that we're in, so one thing too is that this tool I made, I'm running it in Mac, but I don't have a good X handler set up, and for some reason Xquartz doesn't like to play nice with this. So if you're running this on Linux, you get different terminal windows that pop up with, like if you're running the Modbus module, then you would get windows that pop up and actually show you the addresses and the coils instead of having to kind of hop skip back and forth. In this case, you'd actually get a terminal pop up that tells you the vendor commands, right? So what we're going to do here, we're just going to do basic 201 command. I can't remember if it was control or FNA. Yeah, definitely. Oh, I forgot to put the I. Yeah, so when you're telnetting into this, you got to do Control A and then I, and then you can do 201.0.0, and then it should print out the. Let me do a double take and make sure that's. Oh, my bad. It actually timed out. Don't worry, all is not lost. If this doesn't work, that's fine. I got a video. Okay, that's not working. So I'm going to just pop this open real quick and just kind of show you the tail end of it. All right, that's MQTT sensor. Should be big enough, or not. That's pretty small, actually. But can everybody make that out? It just says ATG tester. It's the same thing I just had. The address localhost 0.0.0.0. Yeah?
Zoom in. Can't see that.
I'm not sure how to zoom in on a PowerPoint video, but yeah. Anywho's, so pretty much when you're using it in Linux, it does have these little terminal windows that pop up and gives you the whole menu for it. And what we have here is we just did, or we're about to do, we have the inventory here. That same command I was running, something happened here where the module timed out. I don't want to take the time to do that, so it'll be time consuming. But then what we can do too, we set up, the command 001 restarts a device, right? So that can be kind of a crappy thing if you have a gas station that has to shut down operations because some dick decided to telnet into it. A lot of these you can interact with because you have, for a lot of the cloud dashboard management platforms, don't have like a VPN or some kind of crazy routing setup where you can do that. So pretty easy to access. Anywho's. Yeah, so there's two types of people in the world of cyber to physical. This might not be concrete, but in my experience, it's the kind of people I meet. First one, we're gonna get an intro into the adventures of, let's just put it on the internet, bro. That's the guy in your organization who just like, let's just put this shit on the internet. Again, not being disingenuous, like I'm sure they're really trying to help out or make things more convenient. However, it doesn't really work. I already gave it away, but his superpower is putting shit on the internet. That's one type, and then on the flip side of that coin, you have his offspring. Got to keep them separated. We have the air gap type, right? Air gapping, and a security by obscurity are the two of the main security tools in most SCADA admins toolset. So the air gap is pretty much just just keeping off the internet at all, right? The only problem with that is that it's not sustainable at all. If you want to achieve that industry relevance, you've got to find a way to play nice with the IT side to constitute these connections and use these dashboards and do all your cool stuff off-site. No person really wants to have to go on site every day just to get the stats of something obscure. So how do we securely bridge the air gap? Let's get into some fun dementals. I'm glad you guys got it. So here, cybersecurity rule number 1, you're not secure. Even if you're secure, you're not secure. Don't think you're secure. Only because the mindset, that little bit of paranoia helps. I don't have to tell you guys about that. So I got this GIF of a guy poking holes into a water bottle. I feel it fits somehow. Then there's Rocco Bodie of Mega 64 and Best Buy hacking everything. That's pretty much how it works from what I know. So in order to kind of really cement this, whenever you're working with trying to bridge the air gap, always assume that these little things can go wrong, right? So I have this this growing text here. You can reflect while that's loading. It's going to be my drink break. Okay, it gets pretty big. So, yep. How do we securely bridge the air gap? So we have your compulsory security methods here. So, employing proper encryption, your AAA, routine vulnerability checks, deploy active monitoring. You should do that for sure. So have a SIM set up or have somebody set up the SOC for you and integrate you. Pointing to myself because that's what I do. And so continued architecture, right? So the things I'm going to get into from here is like a little lightweight threat modeling and some notional network concepts here. So this icon right here, this is going to represent the SCADA device itself, and this right here is just going to be the cloud-based admin management dashboard doohickey, right? So whatever you're plugging into. And this is just a quick setup. You have monitor points. Your PLC is controlling those, which then report to your SCADA, and that goes to your cloud analytics. That's the idea here. So what are we building? SCADA architecture. What can go wrong? Assume everything can go wrong. In this instance, we're doing the SCADA and PLC. And so what that means is incoming communications of something besides what's meant for it. Because it's so rigid and strict in what it can accept, things can air out and break pretty easily if you just send it random shit. So Right here, we just have a quick trust barrier. Obviously, everything that goes out is cool, but you don't want shit getting in, right? So, what are we going to do about it? You want to protect your SCADA network from unsolicited incoming traffic. One way of doing this is by employing. Oh yeah, don't do this. Yeah, don't be that guy. One way of doing this is by utilizing a piece of technology called a unidirectional gateway. These exist in hardware form. One-way data diode that just allows traffic out, but not in. They can be reconfigured to let traffic in whatever periods that people need to come in and do maintenance or whatever. They also exist in software format, though those are hard to find. But there is a tool called hair gap, which at least allows for one-way network traffic going to a receiver, but you do that for like logs or something, right? So, yeah, that's one way of doing it. And then the last part, do we do a good enough job? Just have somebody test, see if they can get in, right? It's a very, very simple concept if you're employing a unidirectional gateway, the easiest test is to try and send shit to it and see if it gets in. If it doesn't, then you're good. If it does, then you got to fix your stuff. So this is the architect from the Matrix. So, so this is the marker where I get into these are the notional things that this just kind of build an idea of some ways you can set up secure architecture depending on the constituents of your network. So it might not exactly work for you specifically, but this is to, again, build that mindset. So right here you see we've got the router, the switch here, and then we've got two different subnets. One is the operational technology network, which you want to keep separate from the IT network, because if the IT network gets infected with something, you get phobos or you get anything like that, then hey, guess what? That might propagate to your SCADA device. The SCADA device is normally a pretty big, hefty, powerful Windows machine normally, or is running on a Windows machine normally. You can get things like OpenSCADA and SCADA VR and stuff like that, but so you want to keep those two networks separate. An example of what to do is have a relay server which can then forward the traffic over a VPN utilizing some kind of network trunking mechanism done the switch. Another way of doing this is having an OT network separate, having your independently segmented network that will really just hold a secondary relay server to send out. Again, this isn't the cure-all be-all, these are just some ideas. And your OT network separate. And I have a fridge in here too because IoT. Next, this is pretty much, so I'm going to reference this real quick. So where this green arrow is, imagine to the left is here, okay? So everything that's this green arrow here is this green arrow pretty much. So here we can see that we have three different subnets here. We have 172.168.3.0/24 notation here. We've got 172.168.4.0, and we've got 172.168.5.0. And it just arbitrarily assigned IPs right here. We've got 172.168.3.90. That's the relay server. That's right here. And it hits a network trunk utilizing the switch's functionality and then sending that over OpenVPN from one relay server to another. That then sends to some kind of proxy, which can then send out to the internet. And then, again, the proxy isn't super necessary, but I like the idea that if it gets sent out to the internet, if something comes back, you can then utilize some kind of reverse proxy functionality and send that to a honeypot, which can then collect information, send it to a network sensor here. Got this little bro box right here, your network intrusion detection system. So basically, we're just collecting intelligence on the network and on what people are trying to do to your SCADA device here. And then right here, also, I like having NIDs on the IT side because we can then collect network traffic utilizing a tap or span port, could be run like Snort or Suricata or something, and then sending that up to a security incident event management platform. So That's one way. I like this model. It's kind of colorful and semi-complex, but the idea is it's got to be a little bit complex because the idea is that you don't want stuff coming back from here and hitting any of this or anything on the OT network at all. So really quickly, I'm going to go through a potential attack scenario that utilizes a disgruntled employee as an attack vector because that can happen. Does happen, can happen, shouldn't happen. So let's say that this is your prospective OT network, and you have monitoring, you have visibility and insight into the SCADA. You're monitoring the SCADA, but you're not monitoring the other choke points like the unidirectional gateway or the your network device facing out to the internet. And you have employee here, he's probably been asking for a raise like 20 times and you keep denying him. He's getting bitter and angry. He turns into a criminal. And so what he does, comes into work one day with a flash drive, decides he's going to plug it right into that damn SCADA device. And so what happens from there, he puts a virus on there, right? Basically turns this into whatever he wants. And what happens is it starts making outbound requests to something malicious, right? CNC server or something like that. And it comes back because he probably also did something to this unidirectional gateway, or if one even exists, to allow that returning communication back. So basically, because you didn't give this guy a raise, he just turned your OT network's huge, powerful device into a Bitcoin miner, all because somebody couldn't spare a few bucks. So, and the reason why you wouldn't really be able to see that is because in this example, you don't have visibility in here. So one good thing to do is that if you have a SCADA network, make sure you're monitoring all your choke points. So from PLC to SCADA, normally your SCADA device will output some kind of logs. You can then aggregate, do syslog-ng or nxlog stanzas, send to a collector server somewhere. And then being able to use the unidirectional gateway and the network device, send those logs as well, or if you're monitoring over tap span port. So make sure you do all your monitoring. This is a gift from hackers. This is a gift from hackers. This is a gift from Matrix. And this is just a very tropey, beepy, blinky dashboard. Don't be scared, be secured, for those of y'all who are watching Practical Jokers. Credit, we're closing up here. I'm kind of getting low on time, so that's all the ICS research that I did, the tools I created. The only thing I didn't really make was the Modbus lab. That's called Modbus Pal. You can Google it. You just run it with Java jar. That's me at the North Carolina Modern Art Museum, staring at the dangly shit, man. And for the IoT MQTT stuff, stevesinternetguide.com helped get me started. He has a lot of really cool projects, test sensors, things like that you can do. And the automated tank gauge, Eric Zhang, I hope I'm saying that right, AKA 0 Day. So back when these things were starting to be discovered, he was one of the few original folks that went and said, oh, this shit's bad. People need to know about it. So yeah, this is how I got into that. So yeah. Done. So I do have the tool Rapid Fire that I made. It's on Bitbucket. It's yours to use. I also need help with it. So, so if you want to get, just email me with anything that you want or need, and I'd have to provision the access for this for you. So, or if you just want to tell me this presentation sucks, you can email me too. But yeah, that is it. Any questions? I think we have maybe 2 minutes left. Cool, I've effectively confused everyone. It's, okay, so you're saying, can you repeat that? Because it's hard to hear. I heard Modbus and gas station. There's a couple of open source honeypots you can try. They normally start off with, by default, they have the 201 function. The inventory function, they have that there. For anything else, you'd have to, it's an easy Python script, right? So you'd have to implement that yourself. But yeah, so Conpot, I think, is one. That's, there's Conpot and there's Tank Fetch, I think. So you just Google one of those and you should find what you're looking for. They're pretty neat. Anything else? Cool. All right, well, hey, thanks for having me.